Okay. Ladies and gentlemen, thank you for joining us for, well, not this penultimate edition of Game Engine Architecture Lecture. We have this lecture, then a Wednesday. Anyone know what's happening Wednesday? Wednesday's going to be a good one. It's going to be a really good one. What is it going to be? It's going to be CMake. Okay, please don't all of you raise your hand at once, but raise your hand if you really enjoyed maintaining separate Visual Studio, Xcode, and Make projects throughout the semester. Now, don't be shy, okay? But also don't raise your hand. You don't have to be nervous. Okay, on Wednesday, that all goes away, all right? Because Ravi is going to introduce the topic of CMake, a very professional tool used a lot in the industry, and it is a meta build tool. Which, what does that mean? Well, it generates, basically you fill out some CMake files, you customize those files, not too bad, and then CMake will generate a Visual Studio project for you automatically, already hooked up in exactly the ways you need. It'll generate an Xcode project for you. It'll generate a Make file for you, so you don't have to manage these three different things manually as you make improvements and add new files and new dependencies to your project, okay? Okay, Austin, why didn't you just introduce CMake at the beginning of the semester? Well, why would I be hesitant to do this? Anyone?
So you can get comfortable with different IDEs.
Yeah, well, first of all, I didn't know CMake, which is a pretty pragmatic reason not to teach it. But I do think there is value in having you interact with those IDEs and, get used to those common questions you answer in each of them. Navigating the UI doesn't feel super academic, but it's kind of that low-level, nitty-gritty, in-the-trenches knowledge that can really help you, especially as you're going to build things or join a team, okay? Anyway, that's why we probably will keep CMake toward the end of the course in the future, but I don't know, maybe I'll have a second thought about that. We're almost done, okay? We are almost done. You are 1 week away from total victory. You have just we've just launched your final week, your final real technical assignment. This is homework number 10. It's going to be your custom feature, kind of the final polished version of it. You're going to be submitting these, not really through Canvas. You're going to submit a web link to Canvas, and that web link has to be to a portfolio page. So if you don't have a portfolio, you'll be making that. It doesn't need to be complex at all, just needs to have a few things. If you already have a portfolio because you've taken one of my other courses, you're good to go. And you're going to embed your engine videos into that page. You're going to have some text to describe what your engine is, what technologies you use. And in most cases, that's going to become the page you list on your resume or you give to a recruiter. Or when you're talking with someone about your engine, or maybe they want to use your engine, you're going to send them that web page, okay? So you're going to complete that custom feature. We're going to give you feedback probably around Tuesday at midnight or so, maybe a bit after midnight. And some of the feedback might be like, here are some things you should think about trying for the final week. I think in many cases, though, we're just going to give you congrats, and we're going to encourage you to keep going because many of you have pretty good ideas for things to work on in this final week, okay? Your grade will let you know if we think you're on the right track, you've got enough scope. And a couple other things you're going to do this week, you're going to move your source code, the latest commit, to a repo that's actually under your control and not our control, okay? So this is when your project hopefully should feel like it's truly yours, okay? It's no longer in the course repo. It's going to be out there on the internet, okay? It is going to be in your own repo. You can decide what to do with it. When you make new commits, a new history will start. We don't want you taking your entire commit history to the new repo. We're going to be very upset if you do this. And the reason is, right, we don't want people finding your repo online and then, going to the commit that gets 100% on homework number 4, and then you got people cheating based on that, okay? over the summer, I'm going to set up some cheat detection based on your repos, but it'd be really nice if you don't do that, okay? And we might eventually have to delete your repo from our course server, and that's the reason we want you to copy your stuff over to a place that's a bit more permanent for you, okay? So you're going to do that. Hopefully it won't take much time. It's not a huge operation. You're going to record a final demonstration video showing off your final feature, okay? Also, I would recommend you show off your engine. Talk a little bit about your engine in general, maybe up front, because like a recruiter's going to see this. They might want to know about your engine in general and not so much about that feature, maybe a bit about the new feature. Okay, but keep that in mind. This is really for people in the future, for recruiters, for colleagues in the future, not just for the staff. Otherwise, we wouldn't have you put it on a portfolio page. We've got some directions if you've never created a portfolio website before. This should make it relatively easy. You follow some of these links. Highly recommend GitHub pages or GitLab pages so that it never goes down and it doesn't cost you a dime, okay? All right, and that's going to pretty much be it, okay? You're going to fill out a couple forms so that we have a database of your engine. We might use it later to like list it in case anyone wants to find all the cool engines that have come out of the course and find you. But that's it, okay? Doesn't need to be a huge thing, okay? Should hopefully be a relatively chill week. One of the strategies I've been seeing, this can become a pretty scary week if you've bitten off a really ambitious task, like you're making an editor or you're trying to do 3D graphics or something like that. So here's the play. Get that web build ready to go, okay? It looks like most people are doing that in just a couple hours. It's a cool task, no slight against that task. But you have that in your back pocket, so in case your ambitious new feature doesn't work, you slip that one in, you get the points, and you're golden, okay? Yeah, don't fail the course because you forgot to submit something, all right, in the final big homework assignment that's not even supposed to be very hard, okay? Another big thing I noticed is that we're really going to want to see this week that you focus on how will normal game designer users access my new feature, okay? You've got some cool hard-coded stuff on the C++ side of things. That's really cool. It's good prototype. This week, make sure that's exposed somehow to your users of the engine who will not have access to your source code, probably, okay? Think about how people will use it. Think about your UX, okay? That's what game engines are all about. We create this technology to make it easier to make games, okay? So you don't want to confuse people. You don't want to make it super hard to use your cool features. As you think about how will people use this, you know, maybe it'll exercise a part of your skill set. You know, maybe you don't use that much, okay? It's really a pretty incredible thing. In most courses, in most jobs, you're making technology for some sort of end user who's not super sophisticated in tech, maybe, right? You're writing a web app for someone who doesn't know any coding. Here, your customer is other programmers, okay? Other engineers, game designers who are probably fairly literate in some basic Lua scripting. That's a pretty cool thing. You're making software for friends. That's what it feels like, okay? Anyway, and this is something I thought about the other day. I feel like when you're first getting started as a junior programmer, maybe at a job or at a university or something, you think so much about like the end product, okay? How am I gonna program this thing? How am I gonna program this thing? But as you become an intermediate and then senior level engineer, I think what you find is you spend more time thinking about how others program. How will others use my tech to make the thing? How can I make choices to prevent them from shooting themselves in the foot or getting confused, right? And that's what my life was like during a lot of this course, okay? I have to write some helper functions to make the autograder fake mock input stuff work. How do I make that as easy and natural as possible so that the students don't get confused and they don't accidentally do the wrong thing? How can I prevent them from using the basic default SDL function and force them to use mine so that I can do that stuff, right? The compiler's gonna enforce that, right? Anyway, it's a really interesting thing to think about. eventually this becomes such a human exercise. It's so unlike the stereotype of programming. You know, the stereotype, you got a programmer in their basement, just working with code all day. Eventually, you find yourself thinking about humans all day and how they program and what they need and what they want. You feel super social, okay? Anyway, something to keep in mind. Okay, that's the end of my tangent. Anyone have any questions about this assignment or the previous one? All right, just to shout out a few of these things. It's kind of like a dream come true. It's kind of nirvana. It's validation, okay? You make a course all about making a game engine and getting good at C++ and rendering, well, not so much rendering, integration of third-party stuff. And then you see these game engines come in, and they got all these wild new tools, okay? I really like this one, Maya, with the webcam tech. Are you serious? So this is, I believe, I haven't watched the whole thing, but I believe this is getting the webcam texture out of the laptop. And it's putting it right there in the face area, which is crazy. Very cool and a really unique custom feature for this engine. I'd like to know what that Lua API looks like. Maybe it's in here. We got people making basic like game editors, right? We got like hierarchy stuff. We can see like what actors are in the scene. We can see what components are going on in the scene. We can see values, okay? A lot of people doing cool editor stuff like this. Very ambitious. Love to see it. And just all sorts of really good stuff. All right, Alex with the super cool editor. I believe this allows you to edit stuff while you're playing the game, like Unity, right? You can edit components and stuff. We got particle systems going on. We got networking going on. We got all sorts. We got accessibility stuff going on. Immediate auto translations of any audio that gets played. Wild stuff. Super cool. Exactly what I was hoping for. And yeah, my heart gets a little bit bigger every time I overhear a conversation of someone planning to work on this stuff over the summer. I'll remind you, it seems to me that the cracked, as the kids say, the cracked engineers that I know, they end up making their own game engine. Okay, right? Nikhil Ghosh, Ravi Bhatt, and I'm not sure, it's kind of a chicken or the egg thing. Do they start working on the game engine and then they spend so much time on it, they get so into it that they become a cracked, crazy programmer? Or do they, they're a cracked, crazy programmer, so they want to make the engine? And I don't know that the answer to that question matters very much. But I hope that you'll find these engines as something you feel good about. Okay? All right? Yes?
Do you have to dig deeper from our custom feature map to final that combine several features together as our final custom?
Yeah. So if you've run out of ideas for your custom feature, or you've gotten a bit bored of it, you want to work on a second one? Sure. That's fine. Okay? Now, the way we imagined it is you develop that first week feature, right? You add depth to it, you add features to it, you make it easier for game designers to use. But in general, the grading on these two final assignments, not super hard, okay? Not going to be super strict as long as we're seeing a very good effort, as long as your engine is, developed and mature, and that's pretty clear. I think you're going to do just fine. Okay. All right. Okay. So that's the case. On Monday, we're going to have some stickers for you. Okay. On Monday, we'll have a final lecture for you, so you're going to want to be there for that. This is a pretty tough course. Okay. We're going to have some course completion stickers that I think have turned out incredibly well, and they're physical objects, so we got to have you here to get them. I'll probably bring them to the jam as well. I don't know where the jam's happening. I might be able to get Ann Arbor Spark downtown for it. That'd be pretty cool, I think. But I'll probably have the stickers there as well if you want to snag some there, okay? And a reminder, you can do the jam from anywhere. You don't need to be there the whole time. You can just remote in and just work on it alone if you want to, your final game, and just show it off at the end to get those points, okay? Anyway, before we get into the exam review, we're going to go through that pretty quickly, and then I want to show you how to clone and then how to build Godot and make some edits to Godot, okay? Before all that, we've got we got another game engine, okay? And this one's going to feel a bit like Mario Maker. We're really off the deep end with our game engines toward the end here, okay? Anything can be a game engine, I suppose. Today we have Little Big Planet. Anyone play that? Anyone heard of it? Okay. This was definitely a game I played a lot when I was, I think, in high school. A PlayStation 3 game. PlayStation 3 got off to a pretty rocky start, but thanks to really good exclusives like Little Big Planet, it started to pick up pace toward the end of that generation. This came out in 2008, so do not compare this to Mario Maker. Compare Mario Maker to Little Big Planet. In fact, Reggie Fils-Aimé, one of the Nintendo bigwigs in that era, literally said that Little Big Planet is the most Nintendo-like game on a different console, and that they were jealous that they didn't have it for the Wii. Okay? So it definitely does have that kind of charm to it. It's a game whose art style is all about crafting. I'm going to show you the trailer here really quickly so you can get a feel for that. So something this trailer is absolutely terrible at is that almost everything you saw there was creatable and created using the in-game editor tools, which are barely shown off. You can get a sense that this game is a 2D platformer. It's very physicsy. There's a lot of grabbing stuff, pushing stuff, things falling around everywhere, and it has a very kind of crafty arts and crafts art style. Let me see here. I want to show you explicitly like what some of the crafting tools look like and how they're presented and taught to the player. Let's see here. Bolts, buttons. Yeah, let's try this one.
By now, your scene should be looking fancier than Mr. Fancy of 52 Fancy Street, West Fancy Town, Fancyshire. So let's fancy up the interactive aspect with buttons. Choose something to connect a button to. For example, an object you put a motorbolt on. Dive into your tools bag and go get a button. Pop it down wherever takes your fancy. Then get ready with your trusty pop-it cursor. See the connector tab sticking out of the button? Grab it by tapping the action button and heave the gagging thing out. Take it over to the object you want to control and press action. On the button tweak menu, you'll find the ability to change what they do, their behavior, if you like. On and off turns them on, or as you might expect if you're very clever, off.
This voice actor just struck me. I've heard that voice actor before. Anyone know? That's right. Anyway, yeah, this is a very British game made by a very British team. Media Molecule over in England made this. And in general, they make very unique games. Their latest project was a game that kind of is a successor to Little Big Planet, a game called Dreams, which has a lot more flexibility. It can handle more genres. It has a lot more power it did much worse than Little Big Planet. In fact, it's been shut down. It only lasted about 2 years. Meanwhile, Little Big Planet is on like their 3rd or 4th game now. Okay? So this is to say that, and this might be a little bit frustrating to us engineers, but more general solutions and more power might not always be what the market wants, what players want. Okay? Having an opinionated game like Mario Maker that limits expressiveness, that confines it. You're making a Mario game, that's what you're making, okay? Sometimes that really focuses a product. It really helps you sell it, okay? Helps people get to what they want to make quickly instead of just having tons of weird tools thrown at them, okay? Anyway, pretty cool stuff. The actual platformer itself has some very unique mechanics that have not really been seen before or since, at least not by me. This is a platformer that has 3 layers to it, right? It looks 2D, but you can actually go into the background if there's no wall blocking you by flicking the stick up, and they'll hop into the background. Flick it down, and the character will hop into the foreground, and you can actually use this to dodge things coming at you. The game has kind of an adaptive kind of Z layer AI in which the game will try and decide what layer you want it to be on when you're platforming, and will move your character there automatically. And it usually worked, but sometimes not always. Made the platforming a bit weird. Anyway, pretty cool stuff in general. That yes, it's probably NP complete. You can watch a video of like a calculator here if you want to. It's pretty wild, as that stuff usually is. But a very impressive product. When it came out at the time, there really wasn't anything like it, okay? This idea that you're kind of playing a game while you make stuff, right? And then you play that thing that you just made and share it with others was really cool. And by the way, Little Big Planet had the Mario Maker thing going with 4-player multiplayer that worked really well, okay? Way before Mario Maker had that. I think Mario Maker 2 eventually got multiplayer. Anyway, pretty cool stuff and very admirable product. Media Molecule has been, I think, having it a bit rough lately, though. So we'll have to, I'm a little bit nervous for that team, okay? A little bit nervous. But hopefully their unique approach sticks around. And hopefully they do too, okay? All right. I think I got through all the announcements. Oh, the one I missed, new course website, okay? And this really isn't a huge thing, but yeah, we now have a website. And what's really cool to me, it shows footage of the engine, talks about why you should take it, if you should take it, why you might not want to take it. Yes, in the back?
I wanted to say studio applications, if you wanted to join Wolverine's on Studio, those should be out by the end of this month. So keep an eye out.
Yep.
If you're not in our Discord, join.
For the summer or fall?
Oh, for the summer.
Okay, for the summer. Awesome.
All
Yep.
applications will be open by the end of this
Yeah, just last night, Sunday night, someone was asking me about that. Anyway, one thing that's really cool is that it also, when you go to one website for one of my courses, it advertises the other two pretty clearly, but not in a super distracting way. And like marketing is really important, okay? Getting enrollment for your courses is really important. Enrollment for this course was fantastic, way better than I thought it was going to be. 55 people or so, which is really good. 494 always does well. Okay, EX440, yes. All right, you want to learn Unreal Engine? It's a really good idea. And this is a course that is lightweight, okay? It doesn't take a ton of time, all right? You can pack that in with a 482 and not have a super crazy difficult semester. And so you also get to learn VR and AR and put cool VR, AR stuff on your portfolio. Why am I advertising this course to you again? Enrollment kind of stinky, okay? And so it's pretty cool stuff. By the way, I sometimes hear that people enjoy my courses, and I sometimes get thanked for them. You don't have to do that. You already paid tuition to take it, okay? But if you want to thank me even more, and this applies to anyone, any course, any product you like, anyone you appreciate, if you like the courses, don't keep it to yourself, okay? Please let your friends and family and your peers know that the courses are cool. You should consider taking them. Because you're going to start to see a ton of flyers and spam for EX440 because I got to get those enrollment numbers up, okay? Anyway, all right, that's a little tangent. Hopefully didn't burn too much of your time. Okay, Let's talk about the exam, all right? The exam was kind of an interesting one. The average and median were relatively high. And the biggest criticism I saw from most of the feedback on the exam, which you can get credit for giving, it's considered one of the assignments on that form, that survey, is that it was pretty long. And so I'm going to be thinking about how we might deal with that in the future. A lot of these questions I don't think were too bad, and most people seem to think they weren't too bad, but there were a couple things that were really tricky. No one got 100% on this exam, and that mainly comes down to one question, which I regret not clarifying a little bit, okay? So I'm going to clarify that for you now. Most of these, let me see, multiple choice, not super hard, okay? Ironically, one of the funniest ways people messed up these was when it said circle 2, but only one was circled, okay? That was mildly fun and not super painful. Only 1 point lost, not a big deal. These matching was generally not too tough. I did get some interesting comments in the feedback as to like, 40 points for all this matching. Like, did it need to be that big? The reason there's so many points in this early section is because I wanted the exam and the exam grades to be higher, and I wanted the exam to be easier. So I overloaded the section that was kind of a little bit simpler so that, you could get a big chunk of points, hopefully. Not the easiest, certainly not easy, right? There's a lot of stuff to know. But if you're into these engines, if you're kind of keeping track of why these engines were interesting, why they showed up at the Game Engine of the Day, I think there's a pretty good chance you were able to work out most of these, maybe only mess up a couple. When we get to the C++ and IDE pragmatics, I think working further and further into the homeworks, getting all the platforms done was really helpful here on the homeworks. These generally went pretty well. On occasion, the data-oriented one right here, you remember this one, right? So this is almost like exactly from some of the slides in our lecture, okay? You've got some code that's loading in some structs, right? Now, your system, your operation that you're doing only cares about like one tiny piece of those structs. Unfortunately, with the object-oriented approach we're taking here, you're going to end up loading that entire struct and all that extra weird and extraneous data that you don't need. And you're filling up your cache with fewer objects, which means your cache is going to have more misses probably, and it's just going to run a bit slower, okay? And so we were really looking for something pretty simple on this one, right? Basically, extract those statistics, those little pieces of data, right? Before each character struct had an HP, it had a defense, speed, rel, vel. By the way, anyone know what rel means? Like, what is rel? I was thinking, like, my mind jumped to The Sims when I was designing this for a sec. Oh, it's like relationships, like how social are you feeling? It doesn't really work in a game with like these other RPG stats. Anyway, it's kind of funny that slipped in there. Anyway, separate those out in a data-oriented fashion. Use your index into those arrays as your entity, okay? Getting toward an ECS, right? Entity Component System. And then we're just going to iterate through just those defense values, right? We don't need to load the attack values or the HP or the speed into the array. Into the cache. And that is going to very likely speed us up a good bit, especially if we have a ton of entities that we care about, okay? Yep, and so relatively simple. Sometimes I think maybe if I leave too much white space, they'll think we need more code than we really do need. But anyway, one really interesting thing is that people have dramatically different handwriting. And so some people have gigantic letters and they eat up all the space and then need pages at the back. And some people have very tiny letters and barely need any space. So we leave you a bunch of time, okay? This one, the quarter muncher, right? The kind of arcade style continue screen. This one was generally not super hard. A lot of people did this really well. The tricky thing here is that there are kind of a lot of little cases to focus on. And I probably won't go through all the code here. But basically, you've got some sort of number that's cascading down from 9 to 0. And before it hits 0, you can press space to basically enter a state where, hey, you got some cool, like, yeah, let's retry, a victory, right? Pose going on. So you draw a different image, you draw different text, or maybe no text at all. When that hits 0, you switch to another mode where everything's sad. And you draw a different image, and you draw some different text. And in between that, you're kind of drawing that countdown. So just a little bit of conditional logic in here, nothing too crazy. When you've got pen or pencil and paper, the big challenge here is that it's hard to move around code when you like notice another condition you have to work in that you didn't see before. That's why I told you to have an eraser, and that's why, hey, riddle me this. Do other EECS exams generally ask you for like a pen, like bring a pen? Do they do that? Or is it usually pencil?
Usually pencil.
Usually pencil? All right, that's got to be why, right? So I told you to bring a good eraser, and that's pretty much why. Anyway, not too crazy. This also asked you to use some Lua function calls. And pretty much all of these, I think, were in the glossary at the front. And so, yeah, nothing too crazy. You can compare your code to this. In general, here's how the free-form code sections were graded. And this was a huge pain, okay? There are different solutions to all these problems that are valid. Some of them show up pretty commonly. Like this is a relatively common approach, but there's another approach that's really nice, that's kind of more state-based, enumerating the 3 states you can be in. Let's decide what state we're in, and then depending on the state, we execute different logic. I really like that approach. It's not the one that's on the answer key here. But in general, what I had to do is I had to simulate your darn code. Every single piece of code, okay? And that was a huge pain in the butt. That's why I basically burned like, oh my goodness, like 10 hours a day over the weekend just grading. And then I'd go out for lunch with someone and I'd come back and grade more. What a pain, okay? Anyway, what was really fun was when someone had a crazy solution. Like, what on earth is this code trying to do? We got all sorts of crazy variables in here. There's way more code written than should be necessary for this problem. That was a big pain in the butt. You know why? Because it's hard code to simulate in your head, and you can't just mark it off. Why? Because it might be right, okay? This solution has flown off the rails, and it's in midair, and it's probably going to crash and burn, but you don't know that. And the train might very well land perfectly back on the tracks and stick that landing. So that was a huge pain. Some of these I was able to grade in like 30 seconds, and others I had to study for no joke about 20 to 30 minutes to make out the handwriting, right? Like reference other places where that token was written, but more clearly to figure out what someone wrote, and then try and piece together in my head whether this solution is going to work. Oh my goodness. Okay, I hope you all have a chance to experience that. It was quite enjoyable in a way. Whew. All right. Okay, 100-meter dash. This one was a bit more interesting. And the solution that I really enjoyed about 100-meter dash, the one that stood out as being most clean and free of complications, basically at the start of this game, when your component first begins running, good idea to use on start, on update in this one, on late update, in fact. You really want to use on late update. Right? You collect a set of references, a table of references to all those runners. Now, the instructions on the page right before you makes it pretty clear that, like, you got a bunch of actors whose name is runner. We're not going to be adding any of these during the sprint. We're not going to be deleting or destroying any of them. So you don't have to worry too much, and other components will be editing and altering them, moving them. So you don't have to worry about that. We are just a referee kind of watching these runners, taking note of when they get DQ'd or when they finish the race, okay? So most people collected a table of all those references to iterate through and check the runners at a later date if we want to. A really good solution that was pretty clean was you could also create a second table. That second table is basically just holding some booleans, okay? Some true-false values. that say, hey, is this runner at this index, i.e. in this lane, disqualified or not? Okay. Some people set that up right here in the beginning. Not too tricky, just some iteration. Some people, I think I saw like one solution that was pretty clever. Oh, God, goodness. Oh, wait, did they do that? Oh, no, they couldn't. They couldn't do that. So they tried to do it, but it didn't quite work. They like put a bool onto the actor. Like they added a dot disqualified bool onto the actor references themselves, which is not something you can do. In Unreal, you could do this. But in our engine, all data has to be on components. An actor is a container of components. If you want to add a bool onto a component, you have to grab a component first. You could maybe put it on the transform. That would be very hacky, but it would probably be correct. Anyway, we need to use onLateUpdate because the directions say that you need to do your processing and checking after all other components have finished running in that frame. So the components that might move the runner down the racetrack, like those got to run before we check them. Those are running in onLateUpdate. onLateUpdate is the clear choice to make sure we run later after all that business is finished, okay? We need to check a variable. There's this go variable that might not be true, and we can't really start doing our logic until it is true. So an early out like this, Nathan was not very friendly to the early out strategy. At the last lecture, you remember why he said that? And it's a good reason, okay? Why did Nathan say he doesn't like early outs?
I think one reason he said was you could forget to like good early out before you like close the file or something.
Bingo. The big one is if you have an early out, that means you have multiple kind of exit locations in your function. And that makes it kind of hard to juggle any sort of resource you've opened to remember to close it or to finish your work, basically, clean up. That's a big problem. That's actually bit me a couple times in my career. But every one of these, I will say the entire Sims 4 team was addicted to this. What he said on his team at EA, I don't remember what team he was on at EA, it was like expressly forbidden. At my team at EA, it was all the rage, okay? And the reason is because while it does make you vulnerable to cleanup problems, it does make very explicit your exit conditions, okay? You just go to the top of the function and it's extremely obvious, at what point and in what conditions this function is valid to run in. Anyway, this is all to say coding style differs sometimes, complete polar opposites, sometimes in the same company, okay? So keep that in mind and don't feel bad if you mess up some things. The most important part is to adapt to whatever style your team uses at the moment, okay? So you can better communicate and standardize with your team. Anyway, all right, so once we get into here, like we're running, the race is going, we got to check those runners. So let's iterate through them, okay? And by the way, before we check a given runner, before we focus too much on a given runner, we should check if that runner's been disqualified. If true, we can just kind of, continue on. We can just move to the next runner. No big deal, all right? After we know, and this is kind of an early out if you think about it. It's very explicit. It's pretty nice. After we know we have a valid runner who's not disqualified, we can look at that runner's transform component, and this is very important. Some solutions I saw like grabbed the runner and went runner.x, okay? That's not how composition works. That's not how our engine works. That's kind of the Unreal Engine approach, I suppose. But Unreal Engine also has support for components. So Unreal, you can just do anything in Unreal. And that actually makes it a very messy engine from some perspectives. Anyway, so we're going to grab that transform component. We can do some math. A pretty elegant way to do this is to use the absolute value. Okay, subtract the current y position of the transform from the current index, which is our lane number. And if that's larger than 0.5, then you're disqualified, okay? Go ahead and flip the bool so that in the future we never check this runner again, announce them, they've been disqualified. But Otherwise, we got someone who's valid. We need to check them to see if they're past that finish line. If they are, we announce that fact, we get out of here, okay? So kind of the logic feels like it's actually simpler in this question, but you kind of need to know to use that extra data structure to keep track of who's disqualified and who's not. Whereas the previous Lua question is a little bit, the logic is a little bit more complicated, but you don't need anything too extra, okay? It's a little bit simpler. You don't need to mess with tables or do any iteration, okay? So they're both hard and they're both simple in their own way. One thing that I saw a few times in my initial thought for a solution here was this kind of tough solution where you actually remove the actor directly from the runner's table. If they're disqualified, you take them out of the table. This is tricky, okay? Why is this a little bit prone to issues if you do it this way? Some people did it this way and got full points, but most got nicked for something. The glossary actually has a huge hint here. Yes?
Modifying while iterating.
Yeah, you got to be careful. Remember, we talked about this mid-semester. You can't modify this runner's table while you're iterating through the runner's table. So you have to get a little bit funky with it. You have to have a separate collection to kind of keep track of all those disqualified runners, and then later in the frame, you remove them from the original table. Except that's not the end, is it? Okay, because there are errors here, right? What happens if you have a table that says, I want to remove the runner in lane 1, 5, and 7? What happens when you remove the runner in lane 1?
You don't do it like in a full iteration and start shifting things down and start moving things.
Yeah, when you remove a runner from early in the list, you shift everyone down, and now all of your stuff is invalid. Okay, you have to do some funky math that looks a bit disgusting to fix this. Or you have to remember to iterate backward through the table. And this is also a fairly ugly solution because, wait a second, did you just move a bunch of runners into different lanes? Imagine someone mid-race gets DQ'd and all the runners immediately shift to their left in a lane. Imagine seeing that at the Olympics. That'd be crazy, okay? The spec doesn't really address this. And so you generally didn't lose points for doing this to your runners. But it's a little bit weird, isn't it? A little bit funky. So that solution was pretty error-prone, pretty spooky, okay? All right, this might be my favorite question because it's kind of fun, but also maybe my least favorite because it wrecked everyone. There was not a single student who got full points on this, though quite a few only got nicked by one, okay? It comes down to how inputs are handled. So let's go ahead and talk about that. We've got a bunch of stuff here that like comprises a game. We got images in a resources folder. We got templates. We've got Lua scripts, keyboard controls, all this cool business, okay? So this question is kind of asking you your knowledge about a lot of stuff, okay, about how our game engine works under the hood and how a frame would progress. One of the funniest things during the exam was there were a couple typos in here, and we fixed them before anyone left, so I don't feel too bad about that, and they were pretty tiny. But one thing that's really funny was like a ton of people, you may have seen them walking up to me, like probably about 60, 70% of the people walking up were to tell me, hey, Austin, I think we got another error. Like, this can't possibly be the first frame because we gave you frame 0. This can't be the first frame. Okay, wait a second. We got baddie number 1. We got a template here, and we've got an override on the transform. The X property's at 6, the Y is at -1. So -1 looks fine. 0 on this row, -1 up here, but 6, wait a second. 0, 1, 2, 3, 4, 5? What? What's going on here? And what was going on here? Because I had a lot of people come down and say, I think you've got a bug here. And I just said, no, there's no bug. And then I would watch them go back to their table, and then like about 60 seconds later, they'd go, oh, and they'd lean back. Yes, Mike?
Input, update, render. The update, you have to update whatever the component is. So
Yeah.
they already updated, and then you drew the first frame.
Yeah, exactly. So if you look at Batty 1 and you look at that template that's getting all its components, let's go look at the enemy template. So the enemy template, right here, enemy.template, all baddies, all enemies have 3 components, okay? And we've overridden the X and the Y on the transform for our first baddie. We didn't on the second one. But if you look at the order in which these run, 1, 2, 3, alphabetical order, these components will run their on updates in. Okay, transform doesn't have any update logic, but enemy AI runs before sprite render. So we need to look at enemy AI. What does it do? Oh my gosh, it checks if we're on an even frame. In frame 0, we're on an even frame. And then it grabs our player, it grabs our transform, it checks to see, let me see here. Oh yes, we move. Okay, right up here at the top. You see this right up here? We move to the left. On even frames, all enemies move to the left, okay? They move to the left, and then their sprite render gets to run. What does the sprite render do? Hey, it looks up our transform component. It uses that transform, and then basically, oh, that's the keyboard control, sorry. Sprite render. It looks up the transform information. It renders to that transform data, okay? So I suppose this was a useful hint. Otherwise, everyone would have messed this up and drawn here on the first frame. But so there's an ordering to how these components run, and it does make a difference, okay? Here, the player presses up, so we move up, then we render at that place. The enemies do not move, no big deal. This is kind of tough because there is a second baddie that's off the screen to the right here, okay? So a lot of students didn't get this baddie creeping into the frame right here, okay? Sometimes the baddie was late, and sometimes the baddie never showed up at all. But there needs to be a baddie right here. This is the frame where almost everyone messed something up. Only a few people didn't. And this comes down to maybe a bit of ambiguity behind what this input down here means. This input right here is saying basically what key is held down by the finger, okay? And so when you look at the player movement keyboard controls, the thing to note here is that it's using input.getKeyDown. So if we just hold down the up key, nothing will happen beyond the first frame it's held down, okay? And so the player does not move up a second time. The player moves up here, but on the next frame, when up is still held, we don't move, okay? Some students got this, some students didn't. And I think if anyone had asked me for clarification, I would have made it during the exam. Because I think what might have happened is that a lot of students assumed there was an event coming in, right? And that was not the case. Anyway, the good news here is that you only lost 1 point out of 10 per type of thing that you messed up, okay? So in general, if you got desynced right up here by missing this, like we didn't hold that desync against you behind, beyond the first point. So in general, it wasn't a disaster, even if you messed that part up early on. Anyway, not much happens on this frame, okay? Nothing is being held down, and we don't move any of the enemies on an odd frame. On the even frame, we move all the enemies after we move the player. This is the first time we've seen down, so we move down. Down continues to be held, so we don't do anything on this frame. Enemies don't move on this frame. This was a tough frame, frame 6. This one might be surprising to people. You see the happy face here on the key. What happens on this frame is that the player is the first thing to move, okay? The player moves up, and then the player is still fine. So we do our sprite render. The sprite render does the draw call, and we are scheduled to draw a happy frame, okay? The enemy moves here, okay? The enemy hops onto the same frame, okay, because it's an even frame, so they move to the left. The enemy then discovers that they are on the same tile, the same position as the player. They then change the player's sprite render's image to KO, and then they turn off keyboard control component on the player. They set it to dot enabled. If you've done homework 7, you know dot enabled is a thing that all components have in our engine. And then they destroy the enemy actor. Okay, so the actor, the enemy, the baddie is gone. The baddie doesn't get a chance to render, okay? Because in enemy AI, which runs before the sprite render, it's been destroyed. All the other components not running. But because the player has already finished getting their render call in, they look happy, okay? Yeah, a lot of people struggled with that one too, okay? Some people got it, and very well done for doing that. On the next frame, it renders the true state of the player, and yep, we're in KO. So I'm sorry for anyone who hoped the player was going to make it. They do not end up making it in most scenarios if you're doing things right, okay? Anyway, the second baddie just kind of continues to move, and there you go. There is an input, the up input on frame 8, but we have had our keyboard control component turned off. So we're no longer checking any of those inputs anymore, okay? That was a harder question than I thought it would be, all right? But it was really fun to grade. It was fun to make. I hope you enjoyed it as well, kind of looking through all this stuff. And if you did a good job on this question, like, yeah, you know the engine, okay? Very good stuff and well done, okay? You know how components work. You know how the kind of composition-based structure works to give flexibility to all this stuff. The hard thing for me was making an interesting simulation where interesting things happened without consuming like 10 pages with a ton of code, okay? That was kind of tough in designing that. This might be my favorite question. I'm not sure. It's the final question, final real question. This is the life cycle creation question, okay? How many of you suspected, I think I gave you a hint to like look at life cycle functions that exist out there in other engines. So you're probably going through the, okay, what Unity lifecycle functions exist on components in Unity, okay? Well, what lifecycle functions exist on Unity that are very similar to the ones here? Anyone know? Has anyone heard of on became visible, on became invisible? These are lifecycle functions that exist in Unity. They're fairly prominent, and they're pretty cool. You want to know when a game object like comes into the camera view, you can use those. You just get an automatic function call when your object becomes visible or not, okay? This is something similar but kind of simplified. It's also much simplified because this is all happening in scene space, so you don't care about the camera's position at all. You just care about, or zoom level, you just care about its width and height. Now imagine if I had snuck in like, there's a super hard version of this question that involves like, oh, we're doing like scene units. The camera is here, and it's got this zoom level, so you have to tell me if this box is visible using a supercharged version of AABB, okay? So good luck with that. Anyway, the directions here tell you what to do, which was kind of interesting because a lot of students went off the rails, not a lot, but a few students went off the rails to do something totally different. And a lot of people added a lot of code where it told you to put just a tiny bit. Add a very small amount of state to actor.h. In this question, your mission is to power up, to bring to life basically an on-entered camera area lifecycle function and an on-exited camera area lifecycle function. And that's, of course, in Lua. So you need to call those Lua functions from C++. You need to keep track of whether something was visible or not in the previous frame, okay? Because we don't care if we're currently there. We care if we switched from being there, from not being there, or to not being there from being there, okay? We care kind of like input.getKeyDown about the delta, about the change in that state, okay? Anyway, so what you can do here on the actor, you can, and most people did this, you can simply have a bool that kind of tracks whether our actor was visible on the previous frame or not, okay? That's pretty easy thing to do. Just add that right there. The instructions tell you that these lifecycle functions should generally be called after the on-late updates would be called for a component, basically right before we render something, okay? We do all our rendering. And so there's this nice 2 gaps here. I imagined you'd either put it in one place or the other. Some students, some tests tried to like put this right in here in this for loop, right behind actor.lateUpdate, which will make it run after onLateUpdate on a per actor basis, but not after all late updates have run, which is what we want. And what the assignment really heavily implies, too, with the way this is all set up. Anyway, and that's basically all the setup you need. Then the question is, we just need to write this consider cam lifecycle functions function. It's kind of a mouthful, huh? But the actual function itself doesn't need to be that crazy. You've got some help here. I think sometimes what's hard on these exams is just kind of remembering what's given to you. And I think on most of your EECS exams that are free form, like your instructors, the staff, have something, some solution they're trying to push you toward, okay? And usually they're not that crazy. If you find yourself having to write way more code than is allotted on the page, it's probably like there might be a simpler solution. There might be an assumption I'm allowed to make here. There might be a tool I can use. Like, for instance, get request for actor, okay? Get cam width, get cam height. These things are here. They're listed because we want you to use them, okay? We're not usually trying to distract you because paper is expensive, okay? No joke. You have to print a ton of pages to get 25, page or 12 page, in this case, exam for 55 students. Think of the poor EECS 280 staff. They've got like 1,500 students. That Xerox machine is going to work, okay? And that bill to print that exam is not small. Forget about color, okay? Hey, I do feel bad about this. I promised you color for the final page. I looked at the bill. No way. Okay, it's going to be black and white. It's going to be nostalgia. I'm going to show you the color version here afterward, okay? Anyway. So the basic approach isn't that crazy. You don't really need the entire page. A kind of clean way to do this is to say my first objective is to figure out whether I'm visible or not on this frame. Well, how do I do that? Well, you've got this nice function here. Okay, it's a static function. So you need to write draw UI request, : get request for actor. Now, if you mess this up, you probably didn't lose too many points. In part because we said pseudocode is fine so long as your intentions are extremely clear, okay? On occasion, some really weird pseudocode came out of nowhere that didn't make much sense, and some significant points were lost on that. But you can use this to get the recurrent request for that actor, okay? If an actor has a component that makes a draw request, you can get that request. You don't have to write that function. We're giving it for you, okay? So you can pass in the this pointer, okay? And you can get the request for this actor. This is, if you look at it, not a static function on the actor. This is a member instance function. So this is a valid thing that you can use, all right? If this was a static function, you couldn't use it. The first thing you might say is, well, is this a null pointer? It was a little bit tricky sometimes. Some students forgot to read the comment. Okay, read the manual for this function. It can return a null pointer if you didn't make a draw call. If that actor didn't have any components that made a draw call, that frame, you get null pointer. If you try and use a null pointer, for instance, in your AABB check, you blow up. Okay, so you lose just a point probably if you mess that up. Another thing that some people did was they used the early out strategy. A favorite of mine, it will blow you up here. Because if you check for null pointer and then, hey, if it's null pointer and you return, a good few students did that, you got a little bit of a problem, okay? Because if we were visible last frame, we had a draw request for this actor, but hey, this frame we don't have one, we can't just bail. We need to do some stuff, possibly, okay? We need to run, possibly, that on exited camera area. Because one way to exit the camera is to kind of move your rendering off the camera, okay? Another way is to just stop rendering, okay? You go invisible. You're no longer in the camera area, okay? Anyway, so that was another tiny penalty if you early outed here, and a lot of people did. AABB, I told you Box 2D wouldn't have its own exception, but I also told you it might show up in some other sections, and here it shows up, okay? The AABB algorithm shows up, and not too crazy, okay? You can use it to figure out whether your box, your draw request box, is in the camera area or not. You can do the approach where you have to hit every condition, the and-based approach, okay? Or you can do the or, where you're like, hey, if I break any of these rules, that's more intuitive to me. Like if I know the left side of my box is further to the right than the right side of the camera, it's like, we're not visible, okay? No way, no how, okay? And you can go through about 4 rules to check that, and then you're free. You know you're not visible. Alternatively, you know you're visible, okay? You determine if you're visible or not. You know from this piece of data you're storing on the actor that what the state was, what the result was last frame. And now you can do some pretty easy logic to either run the on-entered camera area on every component, or you can run the other function if the logic was reversed, okay? At the very end, you need to store the value for this frame in that previous value so that when you go to check next frame, you have something to compare against. So nothing too crazy. One thing was that I think on a very few students forgot that components with on-exited camera area and components with on-entered camera area were here. And so they did something weird, okay? These are listed right here, okay, in the actor. As the name implies, these are auto-filled for you, and they just have the components that have those lifecycle functions. You don't have to check if it has a lifecycle function. You already know it, okay? By the way, this was a very easy and pretty impactful optimization you could have done on homework 7, okay, to get all those speed points, right? Try and avoid checking whether components are there or not. And instead, just that up front. When the component is added, just, check, okay? And then put them into a container that kind of isolates them, okay? All right. Anyway, any questions on this this one? This one got a bit funky. This one got a bit crazy. People tried all sorts of different weird strategies, and it was very hard to kind of simulate all of these in my head, and it took a while. It took quite a while, okay? Not many, but some students had additional pages I had to go through. And in general, a lot of students messed up a handful of tiny things. And if there were certain things you didn't try or get to, you lost a bunch of points because there are a lot of little things in here to check and make sure you're doing it right. But most students did pretty well, and some students got 100%, and that always felt really good. So anyway, this last page, and here you can see it in a beautiful color. You'll see this image for you if you submit to the autograder again, by the way, after the autograders have turned off. Thank you for playing. You give us a name, you give us a logo, doesn't matter how crappy, you're getting those points, okay? And I really appreciated looking at them. I know I have a word that some students stayed way too long on the exam and ate up a ton of exam time just thinking about their name and drawing the logo, okay? And so you didn't have to do that, but I appreciate it. The first person to finish the exam did so in 1 hour and 39 minutes, okay? My prediction, my hope was that the exam would take most people about 2.5 to 3, okay? No one consumed all 4 hours. The last person turned it in with about 10 minutes to go, 3 hours and 50 minutes. I would say, and according to my log, this is a little bit anecdotal, the room was about half full at around 3 hours, okay? And so it was, I think we pretty much hit what we wanted to. But I think a big thing on this exam, and something I can probably fix for next time, is that there was a lot of turning of the darn pages and a lot of temporary memory you needed because you'd be writing on one page, but you need to reference something 2 or 3 pages back. One really clever suggestion, I think came in the feedback form, was to actually next time have one part of the exam that's only for like the questions and the documentation and another part that was for all the answers that you write. That sounds amazing. Make it really easy. You got it separate so you can be writing a solution and really quickly flipping if you need to, or if it's a one-pager, you just have it there and really easily reference it. It's going to make the exam even better, okay? So very good idea. We really appreciate your ideas, okay? It's how we optimize and iterate. If you've taken 494 or 440, iteration is the name of the game, okay? Anyway, any questions on this exam? The answer key is posted. Let me know what you think. In general, I simulated all your code in my head, so you didn't have to have what we wrote in the answer key here. This is just one solution. And I actually even broke open the Lua interpreter a few times to check if certain crazy things you were doing was valid. Most of the time, no. On occasion, the answer was yes. It's like, oh my goodness, this works? Are you serious? Okay. Any questions or comments? If you didn't do well in the exam, exams were never my forte, okay? And you can get unlucky on exams. Sometimes, you had it, it was right there in front of you. It just didn't pop into your head. Or you didn't notice something, or you were a bit nervous. That happens, okay? What you'll do is you'll fall back on your projects, your quizzes, you'll fall back on all the other good things you did in the course, and that's going to save you, okay? This exam was only 25%. That's low for an EECS department exam. The reason why is because I don't like exams very much either, and we want to make sure you have a good chance to recover if you work really hard, okay? So hopefully, if you need to do that, you can do that. All right. Anyway, you've got your exams up here. I do not want your exams, okay? Do not give them back to me. Some of you did that. And you can come get your exam if you want to and have fun with that, okay? All right. So I want to talk with however much time we have about an engine that's a pretty big deal, okay? I think more and more so these days, it's the Godot engine. And you know what I'm going to do right now? I'm going to get something started because I'll tell you what, this compile takes a while. So let's go ahead and let's clone Godot. This is the Godot GitHub source. I'm going to go see if I can find my, desktop. Where is it? Do I have a desktop? Where'd my desktop go? Oh goodness, I barely know where I am. Let's go ahead and just clone to my base directory, I guess. Git clone. I can talk more about Godot as we're doing these slow operations here, okay? So Godot is a pretty big deal, all right? It is an engine that popped up really kind of in 2014. Unity was starting to get a stranglehold on the industry, at least in the indie and mobile space, right? Unreal was making their change to fight Unity, and Unity was just a really great engine, super accessible. It's a great team, really. They were very good at breaking stuff. In fact, they were always breaking Unity. But people forgave them because every time Unity broke something, you got a brand new sparkly feature that was awesome, okay? And really, there's nothing like it. So people appreciated that from the team. Unity had a huge exodus in 2023, right? They had a huge kind of scandal and misstep with their licensing. They basically said, we're going to start charging you a fee for every install, every download that your app gets, okay? And that is a huge, huge problem. Surely it would probably make them a ton of money, but it might annihilate certain games, especially ones that aren't trying to make money. So the indie marketplace could be in real trouble. Unfortunately, people looked at Godot and they said, you know what? Godot just isn't quite there. Godot is not the new Unity, the anatomy of a Godot API call. This article blew up, okay? Godot has a lot of problems, all right? In many ways, it is Unity-like, and it's very powerful and wonderful. In fact, I think I can actually show you some cool stuff here in case you didn't use it. But for the first few projects, let's go ahead and create a new project. We're going to call this Godot Experiment. I'm going to create a new folder here, okay? And I'm going to go ahead and create it. Godot is going to remind you a lot of Unity, okay? You can right-click and fly around a 3D environment. You've got something like a hierarchy on the left-hand side and a resources, assets folder toward the bottom. On the right, you have an inspector. When you enter into Godot, you first create a node. This node is called spatial, okay? And this is actually your level. I'm going to call this, let's call this level 1, all right? I want a box. Let's say I want a box. By the way, level 1, this is a scene. Think of it that way. Nodes can be scenes. Scenes can be nodes. Nodes are also game objects. Nodes are actors. Nodes are also components. In Godot, it's nodes all the way down. Okay? Everything is a node. And it's quite an interesting, in some ways very elegant approach. Anyway, we can quickly create stuff. I want a mesh. I'm going to click a mesh instance. And I'm going to go over and customize that mesh instance. I'm going to call it a cube. Now I've got myself a cube, okay? I'm going to actually rename it cube, okay? I can take this cube, I could drag it into my resources folder to create a prefab, okay? It's not called that. It's not called a template, but that's what it is, okay? It's called a scene. This is pretty unfortunate. Godot's made a lot of weird naming choices, but now I've got this template called a scene for my cube. I can just kind of bring this out anywhere, and I can edit this scene like I'm about to do. I'm going to make it really flat like this. And when I go back, all of my templates have changed, my template instances, okay? I can do all sorts of fun stuff. I can say, hey, I don't want just a bunch of cubes in my level. Oh, they all parented themselves. We didn't quite want that. I don't want just a bunch of cubes in my level. I want a camera to see them through. I'm going to type camera. I'm going to grab myself a camera node, okay? I can now bring this thing out just like if I have a camera in Unity, okay? I can now rotate it. I can do some fun stuff. Now I'm going to save, call my level 1. I'm going to save my level 1 into a scene. I'm going to run my scene. Yep, run the current scene. And look at that. Oh, here we go. And there we go. Pretty quick, right? As far as logic goes, I think this is the C# version of Godot. So just like Unity, we can attach a C# script, right? Boom, there we go. I'm going to call this, let's call this moving cam. I can attach it to my camera, and now I can actually write C# code to do interesting stuff. Now there's a built-in editor, but I can switch this to be, let me see here. Can I go mono? Yep, right down here. I can switch this to be Visual Studio or Visual Studio Code. When I switch it to Visual Studio, I can then go and double-click my movingcam.cs file. It'll open up in Visual Studio. I'll get that wonderful autocomplete. It'll be really great. Meanwhile, let's check back on our clone. It's now done. Now what I need to do, I need to go into this repo. Okay, what's my repo called? Do you see it anywhere? Let's see. Oh, it's Godot, okay? Here we are in the root Godot repository, okay? You're going to see this weird file called sconstruct. You won't see any CMake stuff. You won't see a make file. You won't see a Visual Studio project. Scons is the weird, make system, build system that they use here. It's called software construct. It's a fairly old one. It's based on Python. What you need to do is you need to do pip install scons, and this will give you scons, okay? It is, again, Python-based, so you can use pip. The thing you need to run right here is pip install scons. By the way, all of this is like helping you get up and running quickly if you want to. What we need to run is scons target. I'm going to have to look at this. It's going to be scons target equals editor, dev build equals yes, P for platform equals Windows, and VS project equals yes, okay? I'm going to run this, not with pip install, though. How many of you were waiting me to mess that up? Yeah, that's the kind of thing I mess up all the time. It's going to run, and it's going to generate a Visual Studio file for us in a while. In the meantime, though, let's keep going here. I have a Visual Studio project open, but this one is for Godot, that Godot project. I want to make a moving camera real quick, okay? Let's go ahead and move our object. Let's get our current position of our camera. Vector3 current position equals translation dot x. No, actually, is that no? That's already Vector3. We're good. Okay. Now what we can do is say translation equals current position plus Vector3 dot right, or you can also do this. New Vector3 100. Okay. The x here, if we look at Godot, let's go, reload that. If we go to our level 1 scene, look in the 3D view, x is going to be this way. So we're going to see our camera kind of slowly move to the right here, and hopefully we'll be able to see that. This might be too fast. Keep an eye on what happens, okay? We're going to play. Oh my gosh, that was way too fast, okay? Way too fast. Let's go like 0.1 maybe, okay? Oh, F, because like most engines these days, Godot uses floats, okay? And, yep, we got our camera moving, okay? Now, you might say, this doesn't feel very component-y. I've got this actor, you can think of it as an actor, called the camera, and I just put the script directly on the camera. How can I do component-based stuff? Well, here's how, okay? Let's say I want an HP component or a has health component. I'm going to build it for you right now, okay? I'm going to create a base node, okay? Look at that. I'm going to call this node has health, okay? And what I'm going to do is I'm going to, actually, you know what? I'm going to call this something different. I'm going to call this constant movement, okay? That's kind of a component-y name. I'm going to give this a new C# script called constant movement, okay? And here it is, very nice, okay? I can create some variables for this component. I think by doing, let's see here, public int x movement, and I think I'm going to set this to 1 or 0.1. Let's make this a float, and I'm going to add export to it. Okay, this makes the variable visible, and then what I'm going to do is I'm going to go translation equals, no, it's a little bit different, I think. Oh, no, I'm going to do get parent, okay? Get parent dot translation, I have to cast it, I think. Let's go spatial. We're going to cast it, our parent, to a spatial node so that we have the translation to do. Okay, translation equals, let's go vector3. Well, no, we're just going to make this messy for now. Okay, let's go. Can we do plus equals? Maybe that'll work. Vector3, new vector3. Let's go x movement 0, 0. Okay, yeah, I think this might work right here. Okay, so what is happening? Why are we doing this? Well, the reason we're doing this is because this is a component, and in order to make it a component, we have to create that node, give it a script so it has logic. We're going to drag it over here to make a scene, okay? Then delete it up here. Now what we can do is instead of our camera having the moving cam, I think I can just clear this away. What I can do is I can bring in our constant movement scene, and I add it underneath the camera. That constant movement scene is now a component type, and I can drag this as many times as I want to add as many of these components as I want, and I can add it to any object I want too. So if I want these cubes to move, I think they're going to move, okay? Let's really quickly look at these because I think I should be able to edit this. But maybe I can't. Maybe it has to build first, and then it will show up. Oh, bingo. See, I clicked build, and now my variable's right there, so I can edit it if I want to. Let's see if this runs. I actually didn't practice this at all. Look at that, right? We now have a component set up, okay? I can move my camera. I can move my ground tiles. I can move whatever I want, okay? I'm actually going to take my camera. I'm going to make it move slightly faster than that block. Okay, so you'll get this delta here, right? Yep, see that? So it's component-based if you want it to be. Anyway, how's Scon's doing? Okay, awesome. So it went ahead and generated a Godot project for us, explorer.exe. I'm going to open up a Explorer window right there where I want it to. How many of you knew you could do that? Okay, very useful if you're using the command prompt a lot. Where's my file? Godot.solution. Looking good to me, okay? Now, what I want to do, you see this right here at the bottom of Godot? Let me see here. What do we got? Okay, I want to run this again, actually. So I'm going to actually rerun Godot. Exit the editor, okay? I'm going to launch the editor. I'm going to load my project up. I'm going to look for some messages. I want to edit Godot. I want to make it do different stuff. I see this message down here. You might have to squint. It's a little bit tiny. It says GD script language server started, okay? Now, I'm inside of my Godot project right now. I can't see anything. I got to go to the, I got to get my, like, let me see. Where's the view? Here it is. Solution Explorer. We're going to see there's a ton of stuff in here, actually. Okay? A ton of stuff. Oh my goodness, so many files. All right? Oh gosh. What to even do? Here's the main file, okay? But I want to change and customize that message we see in Godot. So what am I going to do? Control-Shift-F, okay? Control-Shift-F for GD script language server, okay? Look at this. We found a few places where that string appears, okay? And if you look here, they're using this kind of unique approach, editor node, okay, : there's this static function called getLog. This is like the log where all those messages are, and there's a function on the log object called addMessage, where we can add a message of our type, of our choosing. Let's go ahead and make something custom, okay? Over here, I'm going to add this message that says, hello, EEX498, all right? Now, I don't want this other stuff in here. I don't care about it too much. Let's go ahead and do a build, okay? I'm going to close the Godot I was using to actually like show you Godot, and I'm actually going to do a build here. I'm not sure if this is going to end before we hit 6 o'clock. So while this builds, hopefully it finishes. You never know because like people are constantly editing the repo, so it could crash if Godot's failing to build. Someone broke the build, but we'll cross our fingers, okay? Anyway, why Godot, okay? This is an engine that has started to gain a lot of traction. Its competitors in open source include Bevy, Open3D Engine, but Godot is the one that appears to be emerging from the pack in a big way. And I say that because there was some pretty big news a few weeks ago. What was it? Has anyone heard of this tiny little obscure game called Slay the Spire? Oh yeah, Slay the Spire 2 is a Godot engine project. And that's going to be the first big one. The first big one that really looks like it's going to be high quality and could really drive the engine into the spotlight, okay? Especially because I think they're really sponsoring it, so they're very into this. Slay the Spire 2 will use Godot. It ditched Unity. And I'm just going to say this really quickly. If you go to the sponsors page, there's a certain company called Relogic that is supporting Godot with thousands of dollars per month. Makes you wonder. Anyone know what Relogic makes? A tiny little game called Terraria. Okay, just saying. Terraria 2 is out there, but they haven't said what engine that one's going to be on. Anyway, before Terraria, Sonic Colors Remake used it. And this was a bit of a big win for Godot, also a bit of a disaster for Godot.
Sonic Colors Ultimate is objectively the most broken Sonic game ever made. Don't tell me people are actually blaming the Switch for this. So, recently Sonic Colors Ultimate came out. I have some good news and some bad news. The good news is that it's made with Godot. Yeah, and the bad news is that it's made with Godot and has bugs. Well, at least on the Switch. So who's at fault for this? Is it the engine? Is the developers? Or the Switch? Is Godot even AAA ready? I'm Adrian and welcome to Redefine. For some time now, there is a rumor running around the Godot community that Sonic Colors Ultimate might be developed with Godot. This was confirmed by Skype on Twitter, posting a detailed thread about the game actually using parts of the Godot engine. The news that the AAA game was made with Godot hyped up the community because it's a big deal.
Right? It's a super big deal, okay? Like, there are projects out there that are starting to prove that you can use this open source engine for real deal projects. Very enticing, in part because you have full control over the source code. In Unity, you're out of luck. You are out of luck if you want to do anything that Unity won't allow you to do or won't support. We're still building, by the way. This is why iteration times matter. Eventually, your big C++ project takes half an hour to build. Godot requires no licensing fees. You don't have to worry about paying a dime to anyone if you use Godot. Now, you should probably consider supporting the engine, and most of the teams that use the engine in a big way do support the engine so they can keep it going, get those bugs fixed, okay? Anyway, Godot ranks pretty highly, actually, on some open source rankings. They're just behind things like PyTorch, TensorFlow, Rust, okay? Not super far behind something like Linux. It's an engine that is beginning to really make a dent. They're ahead of Blender, okay? In the open source rankings, at least for this particular ranking. And they are aimed at Unity, okay? That's one of the reasons they support C#. Interestingly, the gambling industry is a big user of Godot, kind of an anchor industry. Anyone guess why? Did I talk about this? Yeah. Your gambling industry, that's a little bit of a seedy place to be working. You want to be careful because maybe Unity gets a big conscience tomorrow and decides they don't want our engine being used for gambling products. Sorry, you're in big trouble, right? Now, I don't like gambling in the slightest, but Godot has an anchor industry. It's not going away, okay? Anyway, it also has a pretty popular subreddit, and Tesla is using it for their in-car dashboard. Did you know that? They're using it for their apps as well. So there's a little bit of visualization muscle going on here under the hood. And if you look at Indeed, the opportunities for Godot devs aren't overflowing, but they're not non-existent. They are there, and it's clearly the number 3 that people are looking for, okay? Not a bad skill to have in your back pocket. Now, the reason I bring this up and emphasize it is because, and we'll talk about this more during our final lecture, okay? Your engines are awesome, and I really hope you continue to use them. But you might decide that you want to not necessarily make your own engine, but you want to contribute to one of the big community engines, okay? And if you know, right, if you can use your skills to advance open source, you raise the floor for everyone. Suddenly, this industry is not gatekept as much by a couple for-profit companies that might tomorrow decide that it's time to squeeze, or that they don't care about indie devs anymore. Not enough money there, okay? And so we're going to need in the future a lot of people who know about open source and know about engines and are willing to marry the two. Anyway, this community is pretty interesting. They bring in about $50,000, more than that actually, every month. So this is starting to look not so much like a tiny open source team, but like a genuine engine team that can keep a real deal engine going and support it with enough features, okay? I'm not sure. Are we done building? Almost? No, we're still going, all right? We're still going. The first build takes forever, okay? Subsequent ones don't take that long. There are some interesting talks. They are very active at GDC, the leadership in the community.
Hi, everyone.
Right. You can watch this talk to get a feel for the kind of state of Godot, right, where it's heading, and areas that are in need of help, okay? You can add new features to Godot, and one way to get started with that is to watch a few of these interesting videos where the lead developer just walks you through exactly how the Godot repo is structured, okay? Right? What is in this folder? What do these files do? Right? If you want to add this feature or fix this bug, where do you go?
Here, you know that there's the project.godot that every project in Godot has. So this project is loaded to the project settings singleton. So the project settings singleton is this, and this is basic configuration of everything in Godot. We have the text server, which is used for internationalization, has a lot of functions related to fonts and different languages. There's the XR server. This is all like game engine stuff in the low.
Right. So they will explain in videos like this why they don't use std : string. They have their own string data type, and they explain the reason is actually Unicode support. Okay. So that kind of stuff shows up. You'll learn a lot watching videos like this, and you'll learn a lot experimenting and playing around with engines like this. Now, we got that pop-up, which means we're done compiling. Let's go. Sometimes, by the way, it says you're not going to compile, but then it compiles. So that's just how it happens sometimes when you get on a big project. Sometimes they lie to you a little bit. I want to make a new project. Let's see if we can create a new folder here. Let's create a new folder if we can. Can I do that? Let's call this blah. Okay. There we go. Compatibility. Let's go. I'm going to call this blah experiment. Okay. Create and edit. When you've got the debug, the like developer built version of Godot, it runs a lot slower. That's something you'll notice. One thing that's really cool, and I recommend you do it, is set a breakpoint in like some of the early code you find that Godot runs. You can then trace backward up the call stack to find main buried in the project, which is super fun. Not going to do it here because we're a little bit over time already. But you know what? When I click output, do you see that message down there? Hello, EX494! Exclamation, exclamation, exclamation. That's how it all starts, okay? You poke around, you prod around, you can find guides online. For instance, when you want to create a new node, there are all these nodes in here you can search through, you can find buried in these trees, right? Tons of different cool nodes, camera nodes, physics nodes. How do you create your own node? What would it take? You can find guides online, you can find videos talking about that kind of stuff. That's how it goes, all right? Godot has certain problems right now. Web export doesn't really work, okay? And it has plenty of bugs. It has pull requests. You can grab any of those. Grab a tiny one. Grab a typo, okay? Grab a typo bug report. Fix up some documentation, and you can start to build a bit of a rep. Get your confidence. Get some pull requests accepted. And then suddenly, you're an open source game engine developer, okay? Contributing in small ways to raising that floor, making sure everyone has access to a game engine forever. This is MIT license. It's the best one, okay? It's the one where, you know, the entire Godot server, GitHub might be annihilated tomorrow. Someone's going to have a spare copy somewhere, okay? MIT software is forever software, all right? And if it sounds like I'm gushing, I'm a little bit infatuated with this engine. There's a lot of problems that Godot has, okay? A lot of their APIs are slow. They're not very natural, okay? A lot of things in Godot 4 are broken. The overall engine just isn't that fast, okay? But at least it's for everyone, okay? It belongs to the community. And if you contribute even a tiny bit to it, I'd say it belongs to you even more, okay? But it will never belong to just a small handful of people. I think that's pretty special, okay? Anyway, I hope that if you're into this, if you're excited about doing stuff with the summer maybe, you got a few spare hours one day, grab a drink, see if you can get Godot building, okay? Might be kind of fun. Play around with it. See if you can build something tiny in Godot that you might have built in Unity in 494 or in EX440, okay? If I build another course, we've already got 494 for Unity. We've got 440 for Unreal Engine. Probably going to use Godot, okay? That's what the LiveOps course is looking at right now, all right? Anyway, lots of cool stuff up there. Lots of cool stuff in the community. Lots of videos to watch. Lots of cool history here. Just getting something to build is a significant filter with these open source projects. Scons is weird, but it is pretty consistent. And it's not that hard to get it building, okay? So there are different directions for different platforms. Lots of good documentation out there. Some of it has typos or is out of date. Good place to start contributing, fixing that up. And if you have any questions about any of this stuff or about what you should be doing this week with your own engines, reach out, okay? DM me or ask during office hours. I'm going to be here for about 90 minutes. And I can't wait to see those videos scroll in as the week goes by, okay? Can't tell you how happy I am to see that you're all independent now. You don't need me. You don't need the staff, okay? That was the whole point, all right? Unleash a bunch of new engine developers out there into the world. There are so few courses doing this kind of stuff, okay? Where are we going to get the next generation of engine developers at, okay? We got a big block of them right here, and they're good ones. I'm super excited. Anyway, I'll see you next time, okay? Wednesday for CMake, you got to be there, okay? And then Monday, get your stickers, final lecture. I think you're going to enjoy it. And then we're done, okay? We'll see you at that final Eggs Jam, okay? See you later, everyone. Bye-bye. All right, take care, everyone. Thank you for listening to my rants online on YouTube, even if you're not a UMich student. All those YouTube students out there, I'll see you later, okay? Hey, you didn't have to take the exam. That's not too bad, is it? Bye-bye.